Hey everybody, how you doing? Hopefully by the time you're watching this video you are a master factorer. And if you are, great. If you're not, I really hope you put in some extra practice over weekend or vacation to get better at it. Anyway, in class today, or yesterday, depending on when you're watching this, we talked about the three different forms that you could have for a quadratic equation. Um, we talked about the standard form, which was ax squared plus bx plus c. It's also called general form sometimes. In fact, the instructions in your math book will call it general form. It's the same as standard form. There's vertex form, which is of this variety. It's helpful because it gives you the vertex. Um, there's factored form, which looks like this. And this is helpful because this form gives you the x-intercepts. Should be noted, you also, now that we're getting into writing different forms of equations, you actually don't need all of the same information on your graphs that you used to. At the end of the day, if you have an equation that's in vertex form, as long as you provide the vertex and one other coordinate, that's fine, that's suitable. And same thing in factored form. If you're graphing a factored form graph, make sure you include the two x-intercepts and then a third coordinate. And it could be any coordinate on the graph, and it'll work. If you're in vertex form, it's awesome if your other two coordinates are the x-intercepts, because that's helpful. And if you're in factored form, it'd be awesome if your third coordinate would be the vertex, but it doesn't have to be. Okay, well, before I get into some examples, this lesson is meant to help you out with page 390, numbers 1 through 6. So take a look at those problems first. If you feel like you understand how to do this without these two examples, maybe you don't need these examples. And this is my first example. They give me an equation like this, and they tell me to graph both equations. That just reminded me that I actually need to bring up Desmos for this particular lesson. And if you're watching this lesson right now, you might want to bring up Desmos to help you out. I'm just going to need 30 seconds to set this up, and I'm setting it up live. Let's see, this is a window capture, and do that. And we're going to do that. And we're going to hit OK, and there it is. All right, let's make this small, though, because we don't actually need it right now. Okay, we'll get into Desmos in a little bit. So it says to convert to standard or general form. I always call it standard. Your book will call it general. Same thing. And then we need to graph both this equation and our answer. So I have 3 times x plus 5 times x plus 5 minus 4. I would next FOIL this x plus 5 and x plus 5 together. X times x is x squared. The outers and the inners, 5x plus 5x is 10x. 5 plus 5 is 25 minus 4. I then distribute the 3, so 3x squared plus 30x. 3 times 25 is 75, and then 75 minus 4 is 71. So this is my standard form equation. Now it says to graph both equations. It's a positive 3 vertical dilation, so I know this parabola is going to be going up. Based off what I see right here, I know that this vertex is at -5, -4, and then I just need any old point. And I could use standard form and just plug in 0, and if I plug in 0, I get 71. So my secondary coordinate could be 0, 71, and I didn't really even need to write down any math to make that happen. Okay, so that's that graph. Now it says graph both equations. What they really mean is to graph them both together. This was me graphing this equation based off this. So I'm going to graph the standard form and make sure it has these two components to it. Okay, so make this bigger. I need to go over here. My equation is y equals 3x squared plus 30x plus 71. And I get a graph like that. I need to zoom out if I'm going to test out that 171 point. Anyway, vertex is here at -5, -4. And up here it passes through the point 0.71. So basically I just checked my work, and I know now that I've graphed it right. All right, that's the end of example number 1. So I put it into standard form, I graphed it using common sense, and then I checked it on Desmos to make sure that it was right. Yeah, so up here, graph both equations, essentially check with the Desmos. Check your problem using Desmos. Or you could also use your graphing calculator if you've been using a graphing calculator. All right, last example today, same instructions, but this time instead of being in vertex form, they're giving me an equation in factored form. I'm actually going to graph it first. I think to make this interesting, let's make it a -5. Because it's a -5 in front, I know it's a downward facing parabola, so it's going to look like this. My x-intercepts, I have one at 3, 0, and I have another one over here at -4, 0. Then, if I wanted to put it into standard or general form, you would start off by foiling these together or multiplying these two parts. So that would give me -5. X times x is x squared, plus 4x minus 3x basically becomes plus 1x, and then -3 times +4 is -12. And distribute the -5, so I have -5x squared minus 5x plus 60, and that's my graph. And then same thing, I need a secondary point, and standard form is really nice for plugging in 0. If I plug in 0 for x, out it's going to pop 60. So that means that this point, let's see, up here, that would be roughly -0.5, so 0 would be at about here. So 0, 60. So this is my graph, and now using Desmos, I'm going to type this equation in, and I'm hoping to get this graph. So I'm going to make Desmos big. I'm going to do it so that this equation is right there so that you can see it. Okay, so instead of 3x squared, it needs to be -5x squared. Instead of plus 30x, I need to change it to -5x. And instead of plus 71, this should be plus 60. And hit enter, and I'm not getting a graph. Oh, it's because it's maybe it's zoomed into the. Oh, it's giving me a right here. It's giving me this warning thing. It says try adding an equal sign. Oh yes, Elliot forgot the equal sign. Watch what's going to happen the minute I put in the equal sign. I'm putting in the equal sign right now. Bam, and you get your graph. All right, let's check this out. I'm going to make this a little bit bigger now, and I just want to make sure the graphs match. So I have a coordinate here at -4, 0. That matches my graph. I have a point here at 3, 0. That matches my graph. Way up here near the top, I have a point up here at 0, 60. That matches. So I have successfully used Desmos to check my answers. So put the form into so graph it first, then put the form into standard, and then check with Desmos or a graphing calculator or any graphing utility to check to make sure that your graph is right. All right, everybody, that's all I have for you today. It's going to get more complicated now. This was the easier one, going from either vertex form or factored form into standard form or general form. I'm looking at the whiteboard from earlier today. And then in tomorrow's lesson, it's going to get harder because we're going to go from standard form into factored form. And then factoring's a little bit harder than multiplying. But anyway, 10-minute lesson. Have a great day. Talk to you later. Bye-bye.